Hi everyone, my name is Brittany and my presentation is on the Earth-like past of Mars. So as you can see from the picture in the top right and just from learning about Mars in this class, Mars is a rocky planet just like Earth, but it's smaller and further away from the sun. So Mars is primarily carbon dioxide, so it's about 95% carbon dioxide. The mean atmospheric pressure is less than 1% of Earth's. The average surface temperature of Mars is -81 degrees Fahrenheit, and Mars is on average 1.5 astronomical units from the Sun. Alright, so next we have a rover named Curiosity that made a new discovery about Mars. So what it had discovered was that there was more oxygen on Mars in the past, and more oxygen means that there would have been more water for a habitable environment. They know this because the manganese levels show like what Earth's are, and it can only be present with water. It can't be formed without some sort of abundance of water. And the oxygen that it once had led to the rocky surface and the red dust that covers the surface of the planet now. So one thing that I was wondering based on this was how the astronomers got their samples. And how they got their samples was from the rover having these little arms that kind of drill into the surface of Mars. So the rover drills into the sample rock that's determined would be useful for our knowledge. They then collect the sample and put it into a spherical container to be sure that it doesn't interact with anything that it wasn't already exposed to on Mars. And then the sample must be large enough to get a sense of the what makes it up. And has to preserve its entirety, but it has to be small enough for it to get back to Earth. So next we have the dust storms on Mars, which, like I said, the oxygen levels in the past led to the surface of Mars being so rocky and dusty and having that reddish color. So the dust storms on Mars are pretty common, and they can send dust particles up as high as 20 miles above the surface. Additionally, it hasn't rained on Mars in millions of years, and the water that was on Mars reduced because it doesn't have a protective magnetic field, which caused the ionization and splitting of the water atoms into hydrogen and oxygen. The oxygen went into the rocks, which is why Mars had the dust storms and the reddish color that it has today. Alright, so next, here's a picture of the Curiosity rover. So this is a little bit about what the rover has been doing currently. So our rover on Mars, Curiosity, recently found tough organic molecules in 3 billion-year-old rock. It increases the chances of us being able to find and determine the specifics about Mars's ancient habitability and possibly being able to figure out if Mars had life in its past at one time. So this picture here is what Mars was thought to look like with its water in the past. So researchers tell us that billions of years ago, 19% of Mars' surface was covered in oceans and lakes. That's pretty incredible compared to Earth because only 17% of Earth is covered by water. However, some scientists disagree and point to the irregular shorelines of the regions hypothesized to have been oceans. Recently, research hints to the creation of a region called Tharsis to explain the irregular shorelines, and with this explanation, oceans before the formation of Tharsis remain possible. So what does NASA plan to do next? They're going to send a new rover to Mars. It's going to be more equipped, but it has a similar design to the Curiosity rover that you saw a picture of earlier in the video. And this rover is going to be sent to Mars in 2020, and it's going to have a similar plan. It's just going to be finding more samples and to try to find out the habitability of Mars that it once had. All right, and last but not least, a lot of you are probably wondering why we should care about these discoveries, but it's important because they point to where life could have been on other planets. It tells us about life years ago and if any of these planets could have had any sort of life or if they could have life now. And it compares our planets to theirs and it kind of just makes a good comparison.